you're told that A, B, C, and D lie on a straight line in that order. The ratio of AB to BC is 3 to 4. And then the ratio of BC to CD is 6 to 7. And so if you know that AB is 9, so this distance right here is 9, what's the length of the whole segment AB? All right. So one of the things when you're using ratios, there's a couple different ways to approach a ratio. One way that you can approach it is to use an unknown multiplier, a variable, to represent some common multiplier between them. So you know that AB times BC, or compared AB to BC, they have a ratio of 3 to 4. That means that AB is 3 times some common multiplier, while BC is 4 times that same multiplier. So if you think of it as being like x, we see that AB is 3x, BC is going to be 4 times that same multiplier, x. And now when we look at BC and CD, we think of it as a separate grouping, so it's not necessarily based on x anymore, but it does have some common multiplier. So between BC and CD, we're looking at 6 times some multiplier. So I'll change the multiplier in this case and call it y. If BC is 6 times y, CD is going to be 7 times that same common multiplier. Okay, so if you think of ratios in terms of these multipliers, what you can then do is go back in now and identify. Based on the fact that AB is 9, what's our common multiplier x going to have to be in this case? 3, right? So we know that x is 3, so if this is 3 times 3, BC is going to be 3 times 4, which is 12. So now we know that distance is 12, so we can use this distance 12 to help us find the common multiplier y. Okay, so 6 times y is equal to 12. What does that mean our multiplier y has to be? 2. And if y is a multiplier of 2, then what's our total distance for CD? 14. And so now you can add those together. You get 9 and 12 is 21, plus 14 gives you 35.